How's everyone doing? Can you hear me all right? Cool, everybody's good? All right. As you heard, my name is Greg Whitworth. I work on Microsoft Edge rendering engine, specifically the layout team. We own everything from the CSS Cascade to box tree generation, intrinsic controls, SVG, all that fun stuff. I'm also a huge fan of Twitter, love Twitter. If you find any Edge issues, please hit me up. On Edge, even if they're not in Edge, but they're Firefox, Chrome interop issues, interoperability is like a main strong point because I was a web dev well before joining the Edge team. So I really want everything to just work. So even if it's just Firefox and Chrome, hit me up. I'll connect you with the right people, file bugs accordingly so that we can get those fixed. Today, my goal of my talk, if I can go to the next screen. Oop, I went too far. I have a cool intro. Hold on, there we go, okay. So the whole goal for today is to help you understand what happens, how we get from the braces that you type in to the end user, basically how the rendering engine gets them there. So I think the biggest thing to take away for this is there's a million ways that you can do things in HTML, and CSS is a beautiful double-edged sword. Because it's so intuitive and so simple initially, just a single property value combination can become a downfall. I'm sure a lot of us have heard the term death by 1,000 cuts. Because we're talking about a rendering pipeline, we're going to do death by 1,000 leaks. I'll reference that throughout the talk. Additionally, hopefully this will help reduce and look into issues that you're running into on various browsers, hopefully file bugs. Additionally, I'll be using a ton of spec terminology throughout the talk, and the reasoning for that, I'll also explain what they mean. Is so hopefully you can get more involved in the editor's drafts. We're always looking for author input. What are we doing in the CSS working group that's stupid? Maybe you have a cool feature request, or so on. We would love to hear it. We would love the feedback. And so also a lot of tutorials, talks, so on, don't necessarily always keep up to date. And those specifications are, I would love to become, hopefully, the single source of truth. A lot of it is jargony and dense and algorithms. You don't necessarily have to focus on that, but it would be great to have more author feedback there. So let's get started. The pipeline. This is a generalized version of the rendering pipeline. You start at networking. You then go to content parsing, HTML, CSS, and JavaScript. The DOM tree is created, which you saw yesterday on HTML Day. Then we go into style computation in the Cascade, layout box tree generation. We move on to the paint and the paint structure creation, and then finally compositing, and then your end user sees it. This is literally for under the assumption on the first navigate. This does not actually start over and get into, for example, the event loop. There are entry points for web developers into this via JavaScript and the DOM APIs that affect the pipeline. Additionally, there's end user input that can affect and cause us to have to flush this pipeline. Notice the directionality of the pipeline. It goes from here over to there. If you come back and you touch something along this pipeline, you will force a reflush of the pipeline, and we have to go additional work. Now, there's some optimizations that we can do. We'll actually touch on a few later on. Since it's CSS Day, though, today we'll be focusing on content parsing, style through to pixels. So let's quickly hit on parsing. It's almost identical to what happens in HTML parsing. Basically, we go character by character, following the CSS syntax specification. And so basically, as you can imagine, we pick out that, hey, this is a selector. We begin building out a collection for this rule set. We also explode the background, the shorthands, into their longhand, so background color. Additionally, we convert the colors into their RGB format. This is done via the CSSOM specification. We move on and do the same thing for border, and then additionally font size. Obviously, this is not a one-to-one to the actual collection store that we have internally in the engine, but you get the idea. At the end of parsing, this is when the CSSOM is created. So if you ever use document.stylesheets, this at the end of parse time, that is when this is created. Next, technically the DOM tree is created. We then move on to style. And this is, we'll quickly hit on some terminology. There's a lot of confusing things because we have window doc and computed style. A lot of people confuse some of these terminologies, so let's go over them real quick. There's declared. This is what the author wrote. My expectation, and I have seen stuff like this, is that it's probably less or SAS computation for the width. It's very precise. Specified declared plus default. In this case, the author didn't write anything, so we fill in its initial value. Then there's computed, and this is the resolution of the specified. So in this case, this is the font size 1 EM. We assume that the rest of the style sheets don't change the font size. So this is converted to 16 pixels. Then this is the result of layout calculations. So with the 50%, depending on its containing block, if its containing block ends up being 600 pixels, we're able to resolve 50% to 300. And then there's actual, and this is UA specific. We'll go back to that one previously. We changed the precision to just keeping 2 decimal points, for example. So this is not necessarily completely interoperable, especially if we start getting into subpixel discussions, but let's not go there. Style computation. So at this point in the talk, did we lose anything? Okay, all right, okay. At this point in the talk, we have parsed out all of the CSS. We've got them into a nice large container of objects. And basically now what we have to do is we have to then go and query the DOM tree, similar to how you do query selector all, on each one of those rule sets to figure out what actually exists within the DOM tree. And this is a good example of those death by 1,000 leaks. If you use, for example, Bootstrap, and you're only using it for one aspect of it, don't include all of it. Because even though, for example, let's say this shaves off a few milliseconds, the engine's still having to do that work. If you work on a team, a small or a large team, audit your CSS once a year quarterly, what works for your team, to determine what CSS isn't used and remove it. That's remarkably helpful because you're saving the engine the work that it doesn't end up having to do, not to mention manageability on your part. So basically, we end up going to a filtering algorithm because we don't want to waste time on styles that you're actually not going to use on this document. We filter them all down, and then we begin doing style computation. The whole point of style computation is that the user agent should have everything resolved except for what requires layout. A good example of this is like the width property. When we exit style computation, we should have a value of auto, percentage, or pixel in order to move forward. I'm a very visual person, and so I think one of the easiest ways to understand what style computation is to look at some examples. So before we have a width of 1 inch, this is an absolute value, so it comes out at width of 96 pixels. A width of 50% we can't resolve until we know the containing block, so it exits still at percentage. The height of calc, 10 pixels plus 2 EMs. Again, we already know what EMs are relative to, assuming that we know the font size, which we do. And then, so this comes out as a height of 42 pixels. Border color, current color, you heard about this earlier. This comes out at the RGB value of the actual current color within the rule set. And then a height of 50 VH. Assuming that's a 1080p monitor and the browser's full height, this becomes a height of 540 pixels. Now we're ready to do the cascade. We've computed all of our values. We have, we've computed all of our values. We've got them in this nice collection store. Now we need to take into account specificity. You've heard it, I'm sure everybody here has heard of specificity. But basically, just to catch anybody up that isn't aware of it, it's a score awarded to a selector based on the kind of tags, classes, IDs, bang importance used within the declaration. Inline styles went out overall unless a bang important was used. As Harry said, use it on everything. Just making sure you're paying attention. All right, so ultimately you end up with a scorecard looking like this with 0 or more. Based on the selector type, again, visual person, let's look at some examples. You end up with an LI of, so it's a universal selector, so it's get a score of 1. LI with a class, you get a score of 11. You have an ID with 2 classes, a score of 121. Now we have an inline style that gets a score of 1,000. And then the color red with a bang important gets a score of 10,000. That said, I'm not here to talk about best practices with selectors. You heard from Harry this morning. He's got a really in-depth knowledge. I actually hit him up while putting this talk together, and he has a great starting point. This is a good URL to get started on best practices dealing with specificity and trying to avoid specificity wars. In addition to specificity, however, we also have to take into account style origins. This is normally not talked about. Style origin is what determines where the style sheet is placed within the cascade. And there's 3 currently specified style origins. There's also virtual origins, but we won't get into those today. There's the user agent, and this is something that renders CSS, so the browser. There's author styles, so you, the web developer. And then there's user styles, and this is the person using the site has changed something somehow that modifies the site. The ordering in the cascade for this is user styles beat author styles, and author styles beat user agent styles. Most people aren't aware of user styles, but I think one of the best examples of this is on the OS layer, setting high contrast, for example. At least in Microsoft Edge, we propagate all this information through into the browser and adjust the entire site based on what the user has done in the OS. So it's very important to allow that user to be able to maintain for whatever reason they have set those up for. So if we go back to our collection, I've added another rule set that's more specific. In addition, right here, got a laser pointer. We have a user that they have set the font size to 25 pixels. So what ends up happening is we sort by origin. So you can see user jumps right up there at the top. We then sort by specificity. If the specificity were the same, I didn't include this column, it's then in document order. So what ends up happening is we go over the DOM tree, we remove any duplicates because essentially the top one wins. We remove these out, they have lost. So if this is our DOM node for fancy button, these would be the computed styles hanging off a fancy button. Now to my favorite part because that's the team I work on, layout. So we've now set the stage. There's absolutely nothing technically representative of what you ultimately want to lay out and show to your end user. So this is where we end up needing to do some box tree generation and get things going, get to the fun stuff. In order to do that, though, I'm sorry, I have to be a little dry and go through some terminology. Have fun reading this text. Bert, where are you? You probably wrote this. Anyways, a block formatting context, also known as a BFC. To me, one of the easiest ways to understand what a BFC is, one of my colleagues has a great explanation. Basically, a block formatting context is created when it needs to lay out that of its children and position them, as well as its geometry is not affected by floats. Good examples of BFCs, here's one, is an absolute position box becomes a BFC because it is responsible for laying out its children in its context. Additionally, flex containers, flex items, grid containers, grid items, multi-column, so on and so forth. You get kind of the picture. The containing block. This is the ancestor block. Remember, I was talking about we have to do layout and resolve styles against. That's what the containing block is. Unfortunately, there's a bunch of if-elses that determine what what your containing block is, and I'm not going to cover all of those here. But if you want to go read them in the CSS 2.2 spec, dutifully updated by Bert, you can go read that here. An example of that is position fixed. We have two boxes here. The light blue box is inside of the dark blue box. Both of them are position fixed. And the light blue box is a child of the dark blue box. It has a CSS setting of right 0, bottom 0. And so what ends up happening is this light blue box, in order to resolve those styles, basically walks its ancestor tree and finds a positioned element other than static, and it basically determines its containing block is that dark blue box. So it positions its inline and block directions to that origin. The dark blue box, because of the fact that, let's say in this example, there are no other ancestors that match that, its containing block is the initial containing block. The initial containing block is the rectangle that is computed based on the topmost box or the page box. So in that same example, the ICB is this red dashed border, which is usually your viewport. The inline direction, I just mentioned this, the inline direction is the x-axis in most cases that you've probably come across on the web. So in left to right, right to left writing modes. In vertical writing modes, it is the y-axis. The block direction is the y-axis in left to right, right to left writing modes. In the vertical writing mode, it is the x-axis. The CSS box model. How many people have seen this? Awesome, good. Okay, so these are the most CSS boxes a CSS box can have. The margin box, border box, padding box, and a content box. Not every CSS box has this many boxes, but these are the most that a CSS box can have. The flow. How many people have heard of the flow? The layout. Oh, decent amount. Okay, so basically the flow, a lot of times you hear it in talks and stuff where it's like, oh, well, that will cause a reflow. Well, what does that mean? That means that you're moving in document order, laying out each child in the direction of the box's writing mode. So basically, if we're in left to right, top to bottom, such as this, and this is our wonderful DOM tree over here, basically, we move in document order. We've laid out our float. We move on to the paragraph, going top to bottom, laying out our content in here. We then move on to the next paragraph and continue laying out. Okay, terminology done. We're ready for box generation. So for each element in the DOM, there will be 0 or more boxes in the tree. So if this is our DOM tree, we have a body with 2 divs, and I would like to posit a use case here. The div on the left is like a clicker button, and the div on the right is going to contain images. You're wanting to become the next Instagram, and initially you just want to say, show images, and you have a pretty background image, or blend modes or something cool. And so basically what ends up happening is we walk this tree, and we generate a box for each. And they're based on their styles, they all get a box of CSS box. You'll notice we don't care what the semantic tags are. because of the fact we only care about their styles and their content in order to do box tree generation. So again, let's say initially in your use case, you don't want this div to be shown to the end user until they click some button for some reason. There's multiple ways you could go about this. You could go about it using visibility hidden. You'll notice our box tree did not change at all, and that's because visibility hidden requires us to take layout into account, and so it needs to take up layout space. Another approach to this is display none. You'll notice we now only have 2 boxes. On the surface, this seems trivial, no big deal. But again, this is that death by 1,000 leaks scenario with the rendering pipeline. Because let's say you publish your site, all of a sudden it goes viral, ends up on these tech blogs, and all of a sudden your tree looks like this. You can quickly see that the rendering engine is doing way more work than is necessary, at least for this first paint. You probably want to wait until the end user actually clicks this to actually make it do all of this layout work. So when necessary, boxes will be generated that are not in the DOM, and these are known as anonymous boxes. This next slide is one of my favorites because I see it all the time. But I'm not using HTML tables for layout, I'm using CSS tables for layout. And so I love this because of the fact, I mean, like in the engine, what do you think happens? We just convert it to using the same code to HTML tables. So basically, you have this div that's a CSS box. Per spec, we have to give it a grid box, which is essentially your TR, and then we give it a table box wrapper, which is per spec again. What it makes me like, I see a lot of sites when reducing bugs, I see the div class TR, div class table, and then div class TD. It's one of those things that once you kind of know that that's what happens, if I were to show you literally an HTML DOM tree, it's literally identical. So, food for thought. Now let's move on to the fun stuff. All right, to me, this is where things start actually getting exciting. You get to start seeing things actually happen. Let's go through a very basic hello world example. Here's our HTML with hello world. The only constraint that we're giving to the layout is a width of 50 pixels. So here's our resulting DOM tree, and here's our resulting box tree. The astute among you may wonder why we've ultimately ended up with 2 line boxes when we only have 1 text node. So let's figure that out. So we start off with our body, which is a CSS box. It's got a width constraint of 50 pixels. Its height is auto, so it technically depends on its content. So right now it's technically 0 pixels tall. But right here, I'm going ahead and leaving some gap in there. We move on to the paragraph. You'll notice that it increases because the initial styles on a block of a paragraph has initial styles for margin, so the height increases. We then move on to the first box. We insert hello world with the content and all the styles associated with it. You'll see that world overflows the box. What we end up doing at that point is we backtrack. We find a break opportunity, which in this case is the white space. And we then send our origin of where we left off and then the content back to the CSS box above us. It then, because it got a break opportunity, it says, oh, you're not done laying out. Okay, well, I'm going to clone all of your styles and everything except for the content, and then pass that box over the content where you left off, and so then you end up with world. Our layout is complete, the heights have resolved, we're done, ready for painting. That is layout in general. We'll just continue to build on it, just like math. Content measure. This is also known as a shrink to fit context, and this is when your inline dimensions depends on its contents. So let's say this is our end result here. We basically have a button floated off to the left with some dummy text that says share it within a nice container there. Our HTML and CSS is pretty simple. We have an article with a button, some dummy text in a paragraph, and again, the button is floated left. The only layout constraints we're applying to this is the article is 400 pixels, min width, and a max of 800 pixels. Added padding and some backgrounds just for styles. Nothing fancy. So resulting DOM tree is this, and our resulting box tree will be this. So let's step through real quick. What is happening? So we have this article with a CSS box. It starts off with a min width of 400 pixels because that's what we said to do. It also has a padding, so it has an increased height here. We then move on to the float. We're in a conundrum though, because we don't know how to lay this out because of the fact we don't know how big it is. Should we increase the min width of its parent? We don't know. Should we go to 500 pixels? Because we don't know the width unless the author explicitly set that, which I did not. So this depends on the content. So what ends up happening is we break this node off the tree, and we go into a special mode of layout, which is basically infinite space. You have unconstrained space. And so what we do is we take all of the content and we lay it out on an entire line. Even if this was like, let's say, that wonderful library that was in Jeremy's talk, every single one of those, we would lay it out on an entire line, which would be insanely massive, and we would measure that. That would be the max width. We then scrunch that content down as small as possible with the longest word without it overflowing, and that becomes your min width of the content. So here we have the min and the max width. We return this information back to the parent, and the parent's like, okay, cool, I totally have space for that. Go ahead and take your max width. So we end up doing that. But this is a float. So we end up having to do something special because, as we all know, the other blocks within this BFC, its inline content, needs to take into account and wrap around this float. So the exclusion area of this float needs to be taken into account for all of the rest of the layout of this BFC. So that's represented by this wonderful pattern that I put here. It is not SVG, I'm sorry. But this is passed down. So in order for us to start laying out our inline origin for any other boxes, it has to be past the margin end of this exclusion area and then past the block end of this margin area for the exclusion. So we move on to the first line, we overflow, we backtrack, just like we did in the last example. We move on to the next one, we overflow again, we copy a new node, and this time we've bypassed the exclusion area, so we're able to now lay out fully. So all of our heights have resolved, we're done, we're completed with layout, we're ready for painting. Fragmentation. Does anybody know what fragmentation is? Like truly knows it? Like one? Chris, you don't count. Okay, so fragmentation. Has anybody ever printed something off the internet and it needed more than one page? Wow, way less than I was expecting. Okay, so that is fragmentation. Basically, you're taking content and you're separating it somehow. And ultimately, you're generating a new fragmentainer, which is the best word in CSS, by the way. A fragmentainer is a box, such as a page box, that's printing, by the way, a column box, or a region box that contains a portion or all of the flow. So basically, this seems very simple on the surface, but when you start looking at your layouts and you say, well, where's a good line to just draw and cut this in half? Not to mention, like, you take grid or multi-column into account, how do you do that in a way that the author actually wanted to do it? It actually starts getting quite complex. So let's take a look at a in-browser version, which is multi-column, which was referenced earlier today. And so here we have a body with a div, and the only thing that we're doing here for the div, and what's funny is I actually set column fill to auto to bypass having to talk about balancing of the columns. So the thing he was explaining, I don't want to get into. So basically all we're doing is we're setting this to 2 pixels, we're giving it a height of 300 pixels. So our resulting DOM tree looks like this, and our box tree looks like this. You'll also notice we get a new box, multi-call box. And our box trees are starting to get much, much more complex. And look how, look at this HTML. Look how simplistic this is. And then this is the box tree generated from that. It's one of those things like start thinking about your websites and just your selectors that are then, and all of the things that end up compounding this. So we start off with the box tree. We have the body. We start inserting the box there. We move on to the multi-call. And the multi-call is like, okay, I have columns of 2, column fill of auto, I have height, so we've now increased the box. Multi-call is aware, okay, I need to generate a fragmentainer. So we'll basically essentially copy the styles from the above box. We'll create a new box. And you'll see, I know this is really complicated math. We need 2. So we take the width and we divide it by 2. That becomes your width for your fragmentainer. We then begin laying out. Just like we would before, we continue to overflow, create, clone, new load line boxes. And then basically we get to the end of this one, and it says, hey, I'm going to overflow in the block direction. And we don't want that because we've set a height and we have a multi-call of 2. So we pass this information back up to the multi-call, which then ends up doing exactly what you would expect. It clones and creates another fragmentainer with the same width dimensionality because we have 2. So we then go through the same process of generating and cloning line boxes, and our multi-call layout is complete. We have resolved and gone down. Our layout is done. But now we're ready for painting. And this, in my opinion, is one of those areas, and to be honest with you, I'm not like remarkable at it, but to me, it's one of those areas that a lot of people misunderstand. And so like I thought it would actually be great to actually touch on it and go over some things, because I think there's a lot of I wouldn't say misinformation, but confusion about how it works and what it does. So let's go back to our beautifully graphic designed Share It button. And then we will reference the specification that essentially talks about paint order. So step one for painting the element is we paint in the background. We then paint in the border. We then paint in its content. This is then, in turn, converted to an image. This image is then sent to the compositor and then ultimately shown to the end user. That said, most websites are not simple. We usually end up with multiple stacking contexts. And stacking context actually helps control layering. I said that, but actually stacking context does not equal layers. And this is one of those things where I wanted to use the same terminology so we can all get on the same grounds. When a browser vendor is referring to layers, they're referring to composite layers. And quite often, Z-index is referred to as doing controlling layering, but it's actually not. But it sort of does. So then what the crap is it? Like, what does stacking context actually do? I'm a very visual person, so let's look at an example. So we have a body with two elements in here, item 1 and item 2. The only thing that's happening over here is I'm positioning them absolute and a z-index other than auto, and this will create a stacking context. So right now they're in technically the same stacking context, but ID of number 2, I went ahead and put it in z-index of 1. Because just like box tree generation and the DOM tree generation, it goes in document order. So paint order would follow that same concept. So what I want to end up doing is showing you that I can get item number 2 below item number 1. So this would be our resulting box tree, and this is the result we're going for, is item number 1. And so let's kind of step through this as well. So you end up with this root stacking context. And then because of our CSS, we've now created 2 new stacking contexts. And so let's move through it. So we start off in this state, essentially with painting. We have a transparent background. We paint in its background. Again, we're following that same methodology with the elements. Because of the z-index, essentially what you've done is you've changed the paint order. We're no longer going in box order. We're going to go based on what you've suggested. So we then move over to this one. We paint in its background. We paint in its content. We then move over to the next stacking context in integer order. And we paint in its background. And we paint in its content. And that basically is what gives you the feeling of controlling of layers, when in actuality you're just literally overriding the same pixels that are on the screen. Visible bounds. So what ends up happening here is at the end of doing box tree generation, basically a structure, and it varies between browser, a structure is created to ultimately get it ready for painting. And there's some paint-specific information that is told based on the styles you've set for painting. One of the things, though, is that there's all kinds of cool creative things that people can do with CSS that you may not want it to depend on layout. A good example of this is box shadow. So you don't want that to affect layout in any way. You wouldn't want that to be taken into account. But at the same time, we need to be able to, as you saw before, we need to be able to paint that somehow. So what we end up doing is we change the visible bounds of the box. And this allows us to paint in this very ugly drop shadow. sorry, I'm not like a remarkable graphic designer here. And that's represented here. So we end up increasing the box to 420 pixels and by 420 pixels to take into account the drop shadow. Now we're ready for compositing. Anybody know what compositing is? You maybe have even done it old school style on like multiple things, moving them around. This is like the next slide I'm going to show you is literally just a joke and an example. I don't want to like see somebody tweet out that this is actually going to happen. But let's say Office 365 wants to bring Clippy back. And so, thank you. So to draw attention to it, they're going to do this really annoying effect, per Clippy nature, and have him pulsate down there because he's like, hey, click me, all right? And the only thing we're going to do here is we give it a class of Clippy because we really like Harry's suggestions, and so we used a class. And then we set an animation pulse of 1 second, infinite, and then we did some pulse transforms here. So what ends up happening is we end up doing heuristics, and we take a lot of information into account when determining layering. But some of it is your CSS. So we start out with this root composite layer, which of course every single website has to have a layer. for us to send the images into. But based on your styles, we've done a heuristic and we figured out that, hey, Clippy should be its own composite layer. So what this does is during Paint, at the end of Paint, we end up producing 2 separate images. We then give all of this information from the box tree, which is ultimately represented in something called, similar to a render tree, it varies by browser, off for compositing. It's aware of everything that you want this to do. And so it replaces it in the same place, but all it's doing is manipulating that image. It's shrinking and scaling it over and over again. It is not going back to Paint. It is not doing anything else. It is staying on the end of the pipeline. Again, we want to stay as far to this end of the pipeline for performance reasons as we can. So this is another one of the death by 1,000 leaks kind of thing. This is actually a very important thing to focus on and try to accomplish. Invalidation. This is where, in my opinion, everybody does terrible perf. Of all the performance things that I have seen, it's bad habits with read, write, modifies in JavaScript, or they're not realizing the impact that their CSS is doing on invalidations of either the screen size or hovers or what have you. So let's go back to our shared button. We're going to add a pseudo class here of a background green with a color of white. And this is what just happens on your hover. Now remember, Paint produced images, 2D images. If I were to walk down right now and I had a Polaroid, they're like ancient, but if I had a Polaroid and it had this picture of a button and I asked you to click it, you would probably look like I'm insane, probably. And you would go, there's no way for me to click this 2D image. But that is exactly what happens. So how does that happen? Has anybody heard of hit testing? Okay, I heard A up and then one hand. Okay, so basically what ends up happening is we have images. And we know all their X and Y coordinates. And so what we end up doing is we keep track of all of the inputs that exist. And there's a multitude of inputs. So like for right now, I'm just going to use mouse movement for an example. We also understand the various states that the mouse is in. So in this example, the mouse has just moved. There's no clicking and dragging, any of that stuff, or selecting. The mouse button is not down. It's just in a basic state, you've moved the mouse cursor. We then pass this off to our hit testing algorithm, which essentially follows something along these lines, where it goes back as far back as it needs to, whether that be the render structure or the box tree. It goes back as far as it needs to and essentially is asking the question, hey, do you by chance know what's in coordinate X, 45 pixels, and Y of 75 pixels? And it says, hey, I actually do. It's this float off to the left. And then basically the question then is asked, well, is there anything I need to take into account? It then says, oh yeah, I have a pseudo class of hover. And it's like, well, that's good to know. So it then says, okay, what are the styles? And we say, oh, well, you need to change the background. You need to change the color of the text. So we then repaint a new button here. We generate a new image. Then this is sent off for compositing and on the next paint beat, because there's a VSync in the hardware, depending on what your hearse refresh rate will vary, is sent off to the compositor and ultimately shown to the end user. And so you get that essentially illusion of interactivity. When you're selecting text, any of it, all of it is still an image. And that like blows my mind sometimes when you think about it. So another way of looking at it is on our render pipeline. So we have the mouse move. It goes into hit testing algorithm, which we then, again, get that answer. We say, hey, yeah, we have a pseudo class that we need to cover. This causes style recalc. And again, remember, we have to go in this direction. But this is where it's so important to realize what your styles are doing. Because we say, oh, you're just changing the background and the color of the text. We say, you're not changing any of the boxes. So we'll bypass layout, and we'll go straight to paint. I think that's like a remarkable thing to understand. I'll actually pick on myself with this one. When I first joined Microsoft, I worked on an internal site, and I was prototyping a new layout. I had these tables, and they had that cool zebra striping background, really like minimalist and clean. I really liked it. And then what I wanted to do was, hey, you're on a table row, like I want to show what data that you're on, what row. So I'll add a nice border around that. Remember the box model? You're changing layout. So what ended up happening, initially it wasn't a big deal. We would mouse over the table row, you get a nice border, and move out of it. Then we put it in and we inserted live data, and the information that we're getting from this is massive. So I'm talking literally like hundreds of thousands of rows on this thing. If anybody understands how table layout works, you actually have to do it twice. Unless you're setting every single column and row size and making it fixed, You have to do it twice because you have to determine, again, we're in shrink to fit context, the size of the column sizes and the row sizes to make them align correctly. And so what would end up happening is basically the opposite of this. You would mouse over a row. We would say, hey, by the way, my border is changing, which would force you into layout, which causes you to tear down the entire table, reset up the entire table, that box tree, then paint and then compose. And the second that you leave that table row, you do the exact same thing again. So it's very important to understand what the engine is doing based on your CSS. And again, it was border colon, like it's so simple. It seemed so simple on the surface, but it had such a major impact on the engine. It really didn't matter which engine you were in. So let's take another example. This time we're going to go from the JavaScript invalidation approach. And all we want to do is move this box 500 pixels to the right. I'm sure if we put this up on CodePen or something, every single one of you could come up with a different way to solve moving this 500 pixels to the right, whether it's like inserting a bunch of blank like text in there to move it 500 pixels, whatever. There's a billion different ways you could solve this. But let's go ahead and look at a terrible example in JavaScript. And let's say we're calling this on every RAF or request animation frame, so essentially every paint beat. And basically we're watching it until it gets too far. But what we're doing is we're increasing the margin box by 1 pixel every single time. So that is the important part to pay attention to. What did we just go over? You want to, if at all possible, unless like there's a very important reason for you to not touch the layout boxes unless you have to. So what happens in this case? JavaScript goes into the DOM. This then forces us to go to style. Because we're changing the margin box, it forces us to go layout, paint, and then compositing, which would then move us, but I'll add in that dashed line. Basically, the margin box just got really big and essentially gave you the appearance that it moved 500. It did move 500 pixels, but it's not the best approach, and that's kind of the whole point of this. A different way of approaching that is basically you could have this ID with an animation of move, and we're just going to translate it 500 pixels to the right. And the beauty of this is because transforms don't have an effect on layout, basically this is done on the compositing layer, very similarly to the Clippy situation. Again, it all depends on a multitude of factors. You're never guaranteed a new layer. Basically, it would be moving just like Clippy and staying all the way off to the right. So I know it's a lot to take in a very short amount of time. I actually finished really well, by the way, in a short amount of time. But I truly think that there's a lot to gain from understanding how the engine actually works, what the impact of your JavaScript and your CSS is doing to the engine at whole. And I'm open and excited for any questions that you have. Sure. Yeah. Thanks.
We do have some. How are browsers even fast? What's the most expensive step, and what can we do to optimize?
That depends on the engine and the context. It truly does. It's like you talk to, for example, if you talk to Google or Firefox and you ask them what the most expensive aspect would be, each one would tell you, oh, well, we need to refactor this part of our engine because that's slow in comparison to this other browser. It really, really does vary. And so I would say, to me, the number one that I've seen commonly is the read, write, modify, also known as DOM thrashing. And the important thing to know is everybody says, oh, well, don't touch the DOM a lot. And that's not actually the point. Again, just like I was showing you there, it's the impact that you've actually caused. Have you caused format invalidations and thus layout and having to go through the rest of the pipeline? Or are you just adding a DOM node for data? Well, that usually doesn't end up doing much down the road. So it's probably not a big deal. But if you like add something into the DOM tree and then you also want to know its width like right away, and then you want to modify it again, you've now flushed the pipeline 3 times. And so like you notice a very obvious problem there. So you need to, and ironically, this is literally all React is doing, and that's why it gets all that performance benefits, is it's batching that for you to solve this problem. Because too many people are, they write and they read and then they want to modify, and so essentially you've flushed because you want the client width, for example, of a box that you just inserted, you're flushing the pipeline 3 times, essentially to just redo something with it, because you usually want that width to then do something with. So I would say there's any number of areas that you can optimize your sites, but I really like Harry's talk earlier this morning where he pointed out, well, this is a like presentational scenario where he's talking about the backgrounds and colors. And then anything that's touching those box models, try to not do that, because we really try to optimize our engines to reuse as much of the layout tree as possible. But depending on how you've attributed the styles, we end up having to tear down some aspect of the tree. So I think it's very important to understand what your styles are doing, whether you're doing that via JavaScript or CSS.
Okay. And aside from using methodology like Harry's, are there tools or tools that you can recommend for auditing and optimizing your CSS?
Sure. Like I think every single dev tool, browser dev tool now has some way to monitor what's happening on the site within your CSS, on your site, so you can actually see the impact. Additionally, if you want to get hardcore on the Windows box, we have something called Windows Performance Analyzer that will give you literally everything about the hardware that's happening at the exact same time, so you can understand whether or not like you're like overloading the GPU, or you're missing paint beats, or you're doing too many calculations and the hardware isn't coming in at the same rate. So I mean, there's a lot of in-depth analysis that you can do. I think starting just at the dev tool layer is enough. And you can basically see those read-write modifies. Essentially, if you see those different waterfalls, if you end up seeing, hey, we did JavaScript and then we hit DOM, and then we did style, and then we did DOM again, and then style, that you're read-writing modifying. It's literally a pattern you can look for. So that would be the big thing to me.
Okay. We're out of time, so we didn't get to take very many questions, but you're going to be around, right?
Oh, yeah, definitely.
Okay, so if you have more questions, I saw plenty others. Just find Greg, I guess. Thank you very much for your talk.
Thanks. Thank you.